Now let's implement the pop function. So at this moment, if I do pop operation, then the first node, which is the front of the queue, data 5 will be removed. So if I copy those three assert, what is left over as a front is, since 5 is removed, it should be 6. And the back is a 6 and the length should be 1. If I do pop again, then length of the queue should be 0. So we are going to implement something like this. So give pop function, then implementation pop is there. So let's figure out how many cases we should consider. So on the left hand side, right hand side, and then when is such case. To do pop, the queue has at least one node. We need to assert that at the very beginning. If we have at least one node, then if this is the only node, then left hand side is queue, right hand side is nothing. If length of the queue is 1, but length of the queue is greater than 1, then left hand side is queue, right hand side is another node. So we need to consider those two cases. So before we do anything at all, make sure that queue is not empty. If it's empty, we cannot do pop. Now if length of the queue is 1, so actually length of the queue is count variable is 1, then we do something else. We do second case. So if this is the only node, then queue front, queue back will be, we are pointing to the same node. So we need to free the memory since this node was dynamically created. So delete either p front or pq. It's the same thing. And then p front, p back should be the initial condition. Null ptr is the value for that. And then we need to decrement the count after successfully popping out the data. And if we have more than one data, then we need to take the very front one out. So which is actually the same as a pop over the stack data structure operation. The pop operation, consider p front is a p top, then we do exactly the same operation. So remember how we do popping out the very first node on a stack. So what you do is we need to set up bypass link to the next one by skipping this one, and then free this memory free. And to bypass means we need to know address of the second node from the front. Address of the second node from the front is here, and this member is p front arrow link member. So p front arrow link is holding the address of the next one. That should be the p front. By doing this one, we set up the bypass link. But if we update the p front this way, we lose address of the first node. So we need to save the address of first node after changing p front, so we can free the memory. So that's how we implemented the pop of the stack. So discard, remember p front, and then we skip to the next node by this assignment, and then free the memory. So that's a pop of the stack, same as a, let me write the same as a pop of the stack there. So let's test it, since we have a main program which I wrote a few test cases already. Run, and then just very minimalistic test cases successfully run.